join us. So you are all welcome to today's class. And don't forget what we discussed last time. And the way, yes, I can see your messages are coming in. Yes. Thank you for that. We pray that some of them will still join. So are we there now?
Yes, sir.
Yeah, today we'll be looking at what we call vector integration. So last week we did with the last class we did everything possible on what we call the differential equation of it. But now let's look at it. In this case, we'll be talking about volume. We'll be talking about line integral. We'll be talking about different things. You've seen the question before. You might not know how to solve it. Then some of those things that seems difficult, you'll be able to solve them now. So in this case, let's R of U equals to R1 of UI plus R2 of U2 of UJ plus R3 UK be a vector. Let it be a vector. Be a vector depending on a single scalar variable. Variable U. Where R1 of U, R2 of U, and R3 of U are supposed to be continuous. Supposed to be continuous in a specified interval. Then we have integral of R of U du to be equals to I integral R1 of U du plus J integral R2 of U du plus K integral RU R3 of U du. Is called an indefinite integral of R. If there exists a vector S of U such that R of U equals to D du of S of U, then integral of R of U du is equals to integral of d du of S of U du, which equals to, when you integrate S of U, what do you have? You have S of U plus C. We all know that. Where your C is an arbitrary constant factor independent of U. Where C is an arbitrary constant factor independent of U. Now, this is definite. But what about indefinite? Let's look at the definite. The difference between indefinite and definite is the indefinite does not have a boundary, does not have a limit, but definite has a limit. That is, it can move from one point to the other. So that's why you substitute the limits. We will see the way we put the limit now. The definite integral, I believe you've done this in your calculus. The definite integral between limit u equals to a and u equals to b can in such case be written as a to b, that is lower limit to upper limit, r of u du, which is the same thing as integral of a is lower limit, b is upper limit, d du of S of u du, which implies such that plus C. So we have A, that is limit of A, B, which implies that S of B, that is upper limit minus S of lower limit. So that is what it's talking about. But now let's look at the application of it. Line integral. Are we there? Can you hear me, please?
Yes, sir, we can hear you.
Okay, line integral. Under the line integral, what are the things do we need to look into? Let's R of u equals to x of u I plus y of u j plus z of u k, where R of u is the position, factor of x, y, z. Define a curve C, joining points P1 and P2, where u equals to u1 and u equals to u2, talking about respectively. So what this thing is telling us is talking about the boundary, is talking about the component, is talking about different area of line integral. Then we'll look at examples. But before then, where do we apply this? We apply it in aerodynamics and the fluid mechanics. But let's look at the main thing. Let A of x, y, z equals to A1 I plus A2 J plus A3 K. And the integral of P1 and P2 of A dr, which is same thing as, what is the R in this case? The R is C close open dot dr, which is same thing as C A1 dx plus A2 dy plus A3 dz. Remember, from the knowledge of vector that we are talking about in the space. So, what does it mean to have, if C is a closed curve? If C is a closed curve, we have it to be integral of this. That's where you have this. Dot the R, which same thing as integral of the closed A1 dx plus A2 dy plus A3 dz. Now, can you please tell me why we don't have IJK again? Anybody, please? Yes. Why we don't have IJK? Because initially, yes, because of what? Say it again. Who is talking, please?
There is a dot, as in a dot product.
Yes, there is a dot.
Lazarus, sir.
Yes, Lazarus, thank you. Because you already said A dot dr, and you know the R is x1, the R is the x. Look at the R, you already declare your R here. Our R is here. R is x of u, I plus y of u, j plus z of u, k. So when you dot the two, when you differentiate the R, what do you have? You have the x, I, you have the x, I, the y, j, the z, k. Then now multiply the two together, dot the two together with A. So you will not have the components again. So I just told you where you can apply it. You can apply it in the application is here in aerodynamic. That is why you can see, and fluid mechanics. That's why you see, when you are talking about aeroplane today or anything on air today, mathematics is always carry the prince is the bedrock of everything they are doing there. That's why it's recommended for people that are doing physics to do this particular course, because they know you must know how to undo your vectors very well, and tensors analysis. You must be able to handle integral. How do we apply it? Where does it occur? If you are doing, you must be able to know the volume, you must be able to know the surface, you must be able to know the area. You can't just walk in the space without know what it contains, or it entails to be able to walk there. So let's look at this. That now leads us to service integral. Service integral. Surface, under the surface integral, what do we have? We have the x equals to n dx. So, but by the time you are doing the surface integral, what are the things that needs to be? So we have this one. This is our x. This is the origin. And here you have z. Here you have your y. So in this case, you have what we call, let's say we have this object here. But at this point, we have this space called n. And from here, you have the x, which is the s is here inside this place. So by the time you begin to differentiate the surface, looking at the object and look at the surface, what happened to the integral? Then the integral, we can say we have integral of a dot, yes? Any question? No question. Now,
Sir, is it S what, sir?
which one? You said?
At the top of the object, sir.
Yes, this is n.
What is it? What is written there after S? Sir?
No, this is after x, this one. This is just
Yes, sir.
this is just this.
Yes, sir.
It's just a particular aspect of that particular object. We pick a particular surface, we trying to depict what is happening there. That particular point.
Okay, sir.
So in this case now, we can now look at the examples. Is an example of a surface integral called the flux of A over X. The flux of A over X, sorry. Then we now have this integral of X. Anytime you see integral of X, it's talking about surface. Phi dx, then phi n dx A cross the X but in case if you have this, the notation, when you have this, is used to indicate integration over the closed surface. Over the closed surface X. I'm giving us those formulas so that by the time we begin to work on them, you remember where to pick it from. Now, let's look at the volume integral. We consider.
Please, can you scroll up a little bit? Some parts missing.
Are you okay with it?
Yeah, yes, sir.
Consider a closed surface in enclosing a volume V. Then integral. Now, let me quickly say this. When you are doing line integral, you have a single integral. When you are doing surface integral, you have double integral. When you are doing volume integral, you have triple integral. Please take note of that. Don't say,
Okay,
oh,
sir.
the question, you said what?
I say, okay, sir.
Oh, okay, thank you. And on that day, the question will not tell you volume integral, but you yourself will know its volume once you have the triple integral. Please take note of that. Are we there now? Can we proceed? Okay. Silence means proceed. Our example of volume integral or surface or space. Yes, they call it space, volume or space integral. Please take note of that. Now let's look at example number one. Example one. If R of U is equals to U minus U squared I plus 2U cubed J minus 3K. So the question is find A, integral of R of U du, and B, integral of 1 over 2 R of U du. Solution. So let's look at the R. The formula, the question says R of U du. It's the same thing as integral of U minus U squared I plus 2U cubed J minus 3K or du. Are we together? Remember, they are all the U, but you have to undo them component by component. So we are undo them component by component is going to be I integral of U minus U2 du plus J integral 2U cube du plus K integral minus 3K minus 3. Minus 3 du. So for us to integrate this one, I believe we still remember integration. Hello, please, I need your response. Shola Adenekan, do you still remember your integration skill? Teslim Babatunde, do you still remember? Ifeanyi, Ozain.
Yes, sir.
Do you still remember your integration skill?
Yes, sir.
Okay. Samuel.
Sir?
Hello. Do
Yes,
you still
sir.
remember?
I think so, sir.
Okay. No problem. Damilola, do you still remember? So what I'm asking is this. Let me just give us this first before I integrate this. When you have y to be equal to x raised to power n, this is just in digress. I will clean it up now. And the question says integrate y. So integrate of y will be in, right? When the person go and integrate the y, it's going to be integral of x raised to power n dx.
Wallahi, ina karatu lecture ne kuma bana gani ina cin maganar sa amma bana ganin abin da sai about. Wallahi.
So when they ask you to integrate this, what does it mean? It is pretty simple. All we need to do is just to integrate this. It's going to be, integration will be n plus 1 over n plus 1. Everything plus c. That is the answer for the integration. So we need to take note of that, but that's not our goal. I just give us this. If you want to write it, you can quickly drop it down. So you will understand anytime you, and the beauty of integration is when you are integrating a constant. You know, when you differentiate a constant is 0, but when you integrate a constant, you have the variable along the line. So please take note of that. Let's move on, because that is the basics. If you don't know the basic, you may not be able to proceed here. So now let's go at u. We have I. What is u? You have u raised to power 2 over 2 minus u raised to power 3 over 3 plus c. C1. We have j. We have 2 u raised to power 4 over 4 plus c2 plus k. They have minus 3u plus c3. So everything boils down to what we have here. So at the end of the day, what do we have? Here we need to map everything together. You have u squared over 2 minus u cubed over 3. Everything multiplied by I. Remember, you have C1, I2. So look at what I will do. Plus here we have 1, here we have 2. So you have u4 over 2 plus c2 We might not put the C because of the J. Minus 3UK. So everything will now be plus C1I plus C2J, then plus C3K. Or minus C3K, whatever you call it. At the end of the day, C1, C2, C3, they are all constant. They are still constant. So you don't need to separate them. You just have to write U2 over 2 plus U minus U3 over 3I plus U4 over 2J minus U3UK plus C. Everything is constant. Where C1J, C1I plus C2J plus C3K, they are constant factor. Please take note of that. Write it down. They are constant factor. Any question? Okay. Okay, let's move on, please. Let's look at the second question. The second question there B, say from A, you don't need to write A again. All you need to do is integral of 1 to 2. The same question they said R of U du will now equals to U2 over 2 minus U3 over 3I plus U4 over 2J minus 3UK plus C. Everything we have 1. So we now put 1 to 2, our limit. Don't forget upper limit minus lower limit, meaning substitute 2 first and minus everything you get from 2, then substitute 1, then deduct them together. So it's going to be here, I'll have 2 raised to power 2 over 2 minus 2 raised to power 3 over 3. I plus 2 raised to power 4 over 2 J minus 3 raised to power 2 K. Plus C minus, open the 1, you substitute 1 to 1 raised to power 2 over 2 minus 1 raised to power 3 over 2 over 3. I plus 1 raised to power 4 over 2 J minus 3 into 1 K. Everything plus C. Automatically C will cancel. When you open this bracket, you have minus C here. You have plus C here. So C automatically cancel. Then we proceed by saying, which implies that We have 4 over 2 minus 8 over 3i plus this one. By the time you do this, you have 4 raised to power 2 is what? Anybody?
2 raised to the power of 4, 16.
2 raised to power 4 is what? 16.
16.
16 divided by 2.
That's 8.
8j, thank you. Minus 6k minus c. Then you open this one with negative. Minus, don't forget, everything I. 1 all over 2 minus 1 all over 3 I minus 1 all over 2 j. Please mute yourself. So remember, you have minus here. It turns to positive 3k minus c. So you can see minus will cancel. This is positive, we cancel. So, but you cannot proceed. But all you need to do is, when you resolve this one and you resolve, it will be component by component. This with this will go to this, and the last one will go to the last one. Look at it. Don't just say, you don't just prompt calculator. Say, yes, I got the answer is 3. No. In this case, you have to do it component by component. If you do it well, you have minus 5 over 6i plus 15 over 2j minus 3k. So that is what the question asks us to do. So lay your hands on other examples in your book and make sure you solve them accordingly. Any question? So let's look at another example.
Excuse me, sir.
Go ahead.
So please, I don't understand why the last C should be minus. I don't, when you're doing the integral, the lower limit, that's when you're using 1. The C.
This
Don't know why
one.
it's minus. Yes, sir. I don't know why
And
this
remember, the
C is
formula
minus.
is here. Look at this.
Okay.
This minus will open this bracket. So this one will turn to minus. Are you getting it?
I'm sorry, sir. I got it, sir.
No, it's fine. Okay. So let's look at it. Before the application, because I would like to move to application, but before the application, let's look at this question. Okay, let me use it to solve the.
Please, sir, can we see the final answer, sir? We've not copied before you move it.
Can you see it now?
Okay, it's okay, sir.
Okay, let's write the acceleration. Let me do this one. Of a particle, I know you've seen this question before. At any time t, greater or equals to 0, anytime greater or equals to 0 is given by, that is time, in this case will be positive, is given by A equals to dv dt equals to 12 cos 2t I minus 8 sine 2t j plus 16t k. So, and the next thing is, I said if the velocity v and displacement r are 0 at t, find v and r at any time, and r at any time. Now, the question is very simple. This is acceleration dv dt, according to the knowledge of physics that we know. Now, for you to get, when you are given v, remember initially we are given the r dt. When you integrate this one, what do it turns to? It turns to r of u plus c, whatever you want to call it. But now you are given the v. You are given the v dt. What does it mean? It simply means you are going to get v when you integrate it. So now let's write integrating. Let's continue. So integrating, we have v equals to I integral of, what is I component? Anybody, please mention it for us.
12 cos
12 cos 2t
12 cos 2t
2t
dt plus j integral of minus 8 sine 2t dt plus k integral of 16t dt. So you have to be careful and smart. You know, 12 in this case, our function of t is the one our target is. So how do we differentiate it? What is the first, for the t component, what do we get? For the I component, rather, what do we have? Anybody? Hello? Anyway, all you need to do is when you integrate this, you are going to have 12 in bracket 1 all over 2 sine. It's going to be 1 all over 2 sine 2t. Go and check your integration very well. I. Then plus, when you integrate this one, it's going to be minus cos 1 all over 2. It's going to be minus. Remember, you have negative 8. Negative 8 over 2 again, cos 2t. Cos 2tj. But this is negative 2. Negative will have cancelled negative here. I hope you agree with me. Then plus 16t squared over 2. Okay. So here, this go with this. This is 6. So we have it to be in this point. We have C. We have 6 sine 2t I plus 4 cos 2t j plus 8t squared. Remember, that is for V are 0. They now said putting at initial stage, what do we have? Said putting V equals to 0 when t equals to 0. We find don't forget this is equals to V. Is that V equals to this one? We find 0 equals to.
Hello, sir.
Yes,
Hello, sir.
I'm with you.
Yeah, I don't understand the value of K. Why is the negative before 8 over 2 is now cancelled out and
When you integrate sine, what do you have?
you have a minus cos.
Yes, that is. Don't forget there is a minus here before. Minus times minus.
Yeah, okay. Thank you very much, sir.
Okay.
I get it now.
So you have.
Thank you very much, sir.
You're welcome, sir. Sine 2 of 0 I plus 4 cos 2 0j plus 8 0 squared. So you have 0 equals to so when you integrate this one plus C1, put it there. So in this case now we have 0. Sine 0 is 0. I plus 4 cos 0 is 1 plus 0 plus C1. So it simply means that this is J, this is K. So at the end of the day, our C1 is equal to minus 4J. Now that we know this, I can go again and substitute my C1 into my V. Let's call the equation of V equation 1. Equation 1. So what is equation 1 become? So equation 1 becomes, so we have becomes V equals to 6 sine 2t I plus 4 cos 2t j plus 8 2t t square k plus C1. Our C1 is minus 4j. Don't forget. So I can merge all the j together by saying V equals to 6 sine 2t I plus in bracket 4 cos 2t minus 4j plus 8 2 square k. Any question? So we can now go ahead and so that our dr over, this is the r dt, will now be equals to 6 sine 2t I plus 4 cos 2t minus 4j plus 8 t squared k. Remember that when you get your volume, by the time you differentiate that volume, you have your displacement. I hope do you remember that? Physicist in the house.
Yes, sir.
Is it correct?
Yes, sir.
Yes, sir.
Okay, so please, we're applying it here. So now we have the r dt. So after we've gotten the volume, then all we need to do, after we've gotten the velocity, we are talking about velocity and the displacement. So all we need to do now is to integrate and get your r. So let's call this one equation 2. Integrating equation 2. We have r equals to I integral of 6 sine 2t dt plus j integral of 4 cos 2t minus 4 j dt, plus k integral of 8t squared dt. So if you integrate this one, what do you have? So if you integrate this one, what do we have? We are going to have negative 3 cos 2t I plus 2 sine 2t minus 4t J plus 8 raised to power 3, 8 over 3, C cubed plus C2. Then we substitute, we make R also to be 0 and T to be 0. At R equals to 0 and T equals to 0, we have 0 equals to minus 3 cos of 0 I plus 2 sine 2t 0 minus 4 of 0 j then plus 8 over 3 of 0 k plus C2. So at the end of the day, what do we have? We have negative 3i plus 0j then plus, these are turned to 0 also, 0k plus C2, which implies C2 is equals to 3i. So we can go back to our equation 2 and substitute our value there. We go back to equation 2, what do you have? So equation 2 becomes R equals to 3 minus 3 cos 2t 2ti plus 2 sine 2t minus 4t j plus 8 over 3 c raised to power 3k. Any question? Any contribution?
Hello, sir.
Yes?
From the equation 2 we have, I think we have 6 and 2 ti.
We have what?
6 sine 2 ti plus bracket 4 cos 2t minus 4 bracket close j. Why are we having 3 minus 3 cos 2t at the end of it here?
Remember, when you resolve this question 2, equation 2, when you resolve this one, you first of all, when you resolve it, you equate t to be 0 and r to be 0 to get your C2. Your C2 in this case is 3i.
Yes, sir.
So substitute C2 back into this equation. So if I put C2 as 3i, I have I here again. Another I is here. We match the 3I and negative 3 cos 2t I. We match them together. Apparently, the way we did to the C1. Remember, C1 was 4, negative 4. Yes, it's negative 4I, J. That was why we see, look at it. Look at it. So after that, we match this J together, we have this. Alafi, are you there?
Yes, sir.
Is it clear now?
Yes, sir.
If it's not clear, let me explain. This is what I did. When you integrate this,
I'm not quite clear there.
okay, just calm down. When you integrate this one,
Okay.
integrate sine 2x, sine 2t, you will get negative, you will have, I just jump a step here, which I believe all of you know it. Let me just do it in this place.
Yes, sir.
When you integrate it, you have minus 1 over 2. Okay, let me just do it this way. 6 is a constant together with c. You can't separate them. You can't integrate t. You can only integrate t if it contains t. 6. If this 6 contains t now, you can integrate it separately. But it's not contain t. It's together with this sign. So I place this boundary here. I said 6. My answer for the function of sine will be minus 1 all over 2 sine 2 cos 2t. Right?
Yes, sir.
Cos 2t. So this will go with this. So you have it to be minus, you have it to be what? Minus 3 cos 2t. That is it.
Yes, sir.
And that is what we have here. Now, and I have another cos, and I have cos. Remember that the one I'm solving, I have it to be minus 3 cos 2t I plus 3i. 3i is this one that I got from C2. And I know they are the same component. I can match the two together.
Yes, sir.
If I write it this way, minus 3 cos 2t plus 3 all I is the same thing as when I said 3, I bring the positive front, minus 3 cos 2t I. Any questions?
No, sir.
What I did is just to match all the components together. That's what I did.
Yes, sir.
You're always welcome. So let's quickly look at another example. Our time is fast spent, but I have another class, but let me still solve this. I have I have 2 more examples to go. You are the one writing 3. If A is equals to 3x squared plus 6y I minus 14yz j plus 20xz squared k. Evaluate integral of a dr dot dr from 0, 0, 0 to 1, 1, 1. Along the following path. Along the following path C. That is A. S is equals to T. Y equals to squared. As Z is equals to T cubed. Are you getting it? B. The straight line the straight lines from 0, 0, 0 to 1, 0, 0, then to 1, 1, 0, and then to 1, 1, 1. C. On the C, I have the straight line joining 0, 0, 0 and 1, 1, 1. Integral of this, A dot the R equals to close. We have 3x squared plus 6y I minus 14yz j plus 20x z squared k dot the x I plus the y j plus the z k, which is the same thing as integral of c 3x squared plus 6y dx minus 14y z dy plus 20x z squared dz. So we're asked to solve this problem. Of which I believe we can do it very straightforward. This is part of the line integral solution. Now let's look at it. If for A now, let's sum for A. Remember, A said if x equals to t, y equals to t squared, z equals to t cubed. The point 0, 0, 0 and 1, 1, 1 correspond to t equals to 0 and t equals to 1, respectively. Then integral will be a dot the r, which is the same thing as t equals to 0, 1. So we have this one to be, remember, anywhere you see x, now let me change it now. When you see x, you substitute this t. When you see y, you substitute this. When you see z, you substitute this. That is the meaning. So my equation will now change. Will be 3 t squared plus 6t squared dt are we together now?
Yes, sir.
Okay. Minus 14 t squared. Sorry. Our z t cube d dt, our t squared, because they said the y. The y in this case will be t squared plus 20t t cube dt cube. I hope you are getting it. So all we need to do here is just a fun. All we need to do is just to try as much as possible to merge everything together. Look at it. First of all, settle the issue of integration, differentiation before integration. So when you add the two together here, what do you have? You have 9t squared. dt. You can't use dt for all of them because each of them has different t. Y is t squared, z is t cubed. So you handle it the way it is. Plus, or this is minus. Now, you have to be careful here too. Who can tell us what to do in this case? Yes, I'm waiting. What are we going to do? Anybody?
Okay, should be 14 t raised to the power of 6, then the t squared.
So how do we eliminate t squared? How? Okay, let's continue. It is very simple. All you need to do is, so that's why we put it in brackets. Not to differentiate it now. But it simply means the coefficient of this one will be 2. We multiply by 2. And the coefficient here will be multiplied by 3. Is that okay? Are we together? This will be 28 T6 dt plus, remember this is raised to power 2, You settle the, when you settle it, how do you settle this one? Anybody?
That's 60
Uh-huh.
t raised to the power of t raised to the power of 7. T raised to the power of 6.
No. Take it again.
Multiplying 3 by the coefficient by 3. Then the t. That's what I can think of.
What do you get?
That's what I can think of. 60 t raised to the power of 3. The t raised to the power of 6, the t. I don't know.
3 raised to power what? 3 raised to power what?
T raised to the power of 6.
Where do you get 6? I don't understand.
That's 3 times 2.
3 times 2 is 6.
Yes.
What happened to the other t?
It's just having 1. So
Uh-huh.
6 times 1. 6 times 1.
No, you don't times it.
Okay.
Remember that in this case now, we had this one together. What do we have? What do we have in this case?
9. 90 square.
90 squared.
Hmm.
Okay, at this point, we need to embrace law of indices now.
Okay.
I think we need to employ a raised to power n multiplied by a raised to power m. The same thing as a raised to power n plus m. Right?
Yes, sir.
So that means if we obey this law, this one will change to what? The first one will change to what, please?
So where's your arrow, sir?
This side.
This. I can't see it. But that's
This
18.
one.
Okay, 18t. 18
No,
t.
not 18.
What's
It's
that?
28.
6.
Okay, this is what we'll do. You guys go and solve it. And let me see your solution. Because you are the only one answering my question. I don't know why.
We are with you, sir.
You are not with us. Then tell us the answer. If indeed you are with me, what do we have? Tell us the answer. What the answer will be.
So I'm not seeing the arrow. That's the problem. The,
No. You are saying the arrow. I'm saying this side. How do we resolve this?
okay.
Can you see it now?
Yes, I can see.
Talking about this one. Before we move to this one.
Okay. That's
Yes. How do we resolve it?
that becomes 14. Okay. Serious.
I'm waiting for all of you.
So if we go by indices, before the t, if we go by indices, you're having 14. The coefficient is 14 and 1. Then 14 t raised to the power of 6. Then before the t square, 14 t raised to the power of 5 actually. Go by indices. The t square.
Not at all.
Please, I can't help you.
I should help you.
Yes, sir.
Who should I help?
All of us, sir.
Aha, people are talking now. You see, I know you will talk. I'm just waiting for you. Look at it very critical and tell me the answer. I will solve it, but look at it too. That is why you are in the class, just for us to rub minds together. At least when you look at what we are facing now, by the time you get to exam hall, you will remember. Okay, let me explain something to us.
Thank you, sir.
Don't thank me yet because you will still be the one to solve it. I'll try and clean this one. As let me clean this one. So we started from this. But how do we get to this point? That is the question. Let's say our A. Let's get A first. Before the R. A is equals to what? We are getting ordinary A. Are we together?
I'm together, sir.
Yes, sir.
T. What is T? T squared. S is T squared, right? Plus
Yes, sir.
6y squared. 6y means 6t squared, Abby. The high minus 14 t squared. Z is 3 plus 20 t cube raised to power 2. This one is j plus k. Are we together? Hello?
Yes, sir.
I need a response, please. Now, which simply means I want to define A before the R. Let's get A right. This plus this will give you 9t squared. I minus, according to the law of indices, A raised to power x multiplied by A raised to power y is the same thing as A raised to power s plus y. So this power, we can add it together by saying 14 t raised to power 5j. Are we together?
Together,
Yes, sir.
20. Now, first of all, resolve this one. When you resolve this one, what do you have? This is another law of indices that say A raised to power n bracket m is the same thing as A raised to power n multiplied by m. So, which means t raised to power 3 in bracket 2 is what? T raised to power 6. Do you agree?
yes, sir.
So it's t raised to power 6. T raised to power 6, and don't forget you have another t. It simply means this is t raised to power 1. So t raised to power 1 multiplied by t raised to power 6 is the same thing as t raised to power 7. So you have t raised to power 7 Do we agree?
Yes, sir.
I agree, sir.
You agree now?
Yes, sir.
Don't forget that is A. Now let's go back to R. Our R is equals to xi plus yj plus zk. So, and we know our R, we know our x to be what, please? What is your S? Your S represents what? Please answer me. Somebody should just answer.
T.
So you
S is equal to
R
T, sir.
equals to Ti plus T squared J plus T cube K. Any question?
No question, sir. Understood.
Good. Now let's differentiate R now. The R dt is equals to what? When you differentiate this, what do you have? Differentiate this one with respect to t, you only have one I. Do you agree?
I agree, sir.
Plus 2t j plus 3t square k. So at the end of the day, I can make R subject, the R subject of formula. I'll just say R equals to I plus 2tj plus 3t square k everything dt. That's all. So it simply means going by this, I can now go back to this formula and said, remember, we have the A. You have A here now. This is my equation 1 or equation star and equation star star. So what do I have in this case? I can match the two together by saying A dot dr will be, let's go to A. Can somebody call A for me?
3t squared plus 6t squared.
3t squared. No, now A cannot be 3t squared again. A.
A is 90 square J square I.
Yes.
Minus 14t raised to the power of 5j.
14t.
14t raised to the power of 5j. Yes, sir. Raised to the power of 5j.
J.
Plus 20t raised to the power of 7k.
Excuse me, sir.
Yes.
If you are merging the two, will the I still remain?
No, you won't get any high again. Plus 20 what?
20t raised to the power of 7.
Don't forget is dots. Remember, I plus 2t j plus 3t square k. So I will down I dot I, j dot j, then k dot k. So I dot I, 9t squared dot, we have 9t squared. Have you seen where you have 28 now? Minus 24 t raised to the power 5 dot 2t will now be minus 28 t raised to the power 6. Then 20 will be 20 times 3. You have 60 t raised to the power what? 9. I know it will surprise some of you. This is what we call the R this is A dot the R equals to this. Every T multiplied by the T. So this is what they ask you to integrate. So you now said integral of A dot the R will be integral from 0 to 1, 9t squared minus 28t6 plus 60t 9 dt. So what's going to be how do we integrate? When you integrate and substitute very well, you have 5. The final answer will be 5. But let's quickly do it first. We have it to be 9t raised to power 3 over 3 minus 28t7 divided by 7 plus 60t10 over 10, 0 to 1. So I want you to punch your calculator for those of you that have the one. So you can now say upper limit minus lower limit. If you substitute lower limit here, you know everything will be 0. So you don't need to bother yourself. Just substitute upper limit alone. So it's going to be 3 here 1, 3 here 3. So you have 3t just have 3 in bracket 3 in bracket 1 raised to power 3 minus 28 over 7 in bracket 1 raised to power 7 plus here 1 here 6 in brackets 1 raised to power 10. So let's punch our calculator. What do you have? You have 3 plus minus. How many 7 is in 28?
4.
Minus 4 plus 6. What do you have?
This 5.
That's the answer. Any question? So when they give you this question in exam, don't just jump into it. You have to know how to analyze it. So you can see why people fail and why some people pass. That is the secret behind it. So please let me stop here.
So I have not written the A. I have not written the last part.
You can do it now. Just substitute the value.
Substitute the value now. We can do it.
Just substitute the value. Which part?
Last part.
Okay.
But it's
Just
okay,
substitute the value. That's all.
It's okay, sir. I can.
Is it interesting? If you can put it in your video, put it in your video. Is it interesting? Remember, we only solve A. You still have B and C. You can solve it by yourself.